Welcome to A-Level Physics. Really glad you're considering physics. It is a fascinating A-Level. I'm going to spend a few minutes giving you a taste of what you would expect in the A-Level. Physics is the science that really underpins chemistry and biology. It's really supported by mathematics, and you probably could say that maths is the more pure form of physics, or it forms the foundation, at least for most of the physics that we do. Physics is the study of how particles interact. Now, that can be particles of all sizes. We'd look at how planets and galaxies interact, right down to small scale, how atoms and subatomic particles interact. And as far as we know, they interact just using 4 forces: electrostatic, gravitational, strong and weak nuclear. The first 2 you've come across at Gcse. The second 2 we do worked on during the A-level course, though you do already know a little bit about them. We've just never really identified them with those names. All physicists work by using observation and then making deductions. There's 2 quotes on the page here from 2 really famous physicists. Richard Feynman said, "It doesn't matter how beautiful your theory is. It doesn't matter how smart you are. If it doesn't agree with the experiment, it's wrong." And then another one from Stephen Hawking, who was very proud of how well we could deduce things from our observations of the stars just from Earth. He said, "We're just an advanced breed of monkeys on a minor planet of a very average star. But we can understand the universe. That makes us something very special." And I kind of think that really sums up physics. We observe and we deduce and we try and put the puzzles together. Why actions cause reactions, how particles interact, where the solar system came from, where the universe came from, big questions about time, about space, but also about day-to-day living. Will that building stay up? What are the forces acting? So within the 2-year A-level course, we look at big scale and we look at small scale. So big scale, just a little taster. This is a picture from the Hubble Space Telescope. It's called the Ultra Deep Field Image. And the telescope was pointed at a very small patch of space. If you held out your arm with a grain of rice, it would be the space that was hiding behind that grain of rice. And it waited and it gathered information from deep space. And this is the picture that we've got. These galaxies, those sort of spirals and bursts of stars, are actually galaxies. The light has taken 13 billion years to travel from those galaxies to our eyes, or to the Hubble Space Telescope. That means we're effectively looking 13 billion years back into the past. And at that time, the universe was only probably 400 million years old. So 400 million years after Big Bang, we're having a picture of what the universe looked like. So physicists will look at that image and then they will make deductions. They look at what the early universe was like. They try and piece together the path from Big Bang to the universe now, thinking about what the universe might be doing in a long time in the future as well. Okay, so down to the nitty-gritty of the course. We teach OCR A-level. It's OCR A. It's a really pretty traditional course, and I cannot hide from the fact that it is really quite academic. It is a challenging course. Saying that, there is a high level of practical and investigative work which really sets you up well for university or kind of the job market. There is maths in most modules. So if you're not a lover of maths, maybe just have a think about that. And there is lots of problem solving. It's one reason why employers like science A-levels. People are really, really good at problem solving because they've had loads and loads of practice. The course is divided into kind of 2 topic areas. There's the mechanics and motion, and then there's electricity and particles. So there are 3 papers in the end. The first paper, 2 hours 15 minutes, Forces and Motion, Newtonian World and Astrophysics. The second paper, Particles, Medical Physics from Year 13, and Electrons, Waves and Photons, so that's Electricity, Waves and Photons from Year 12. The third paper is really, could be on any topic, and it's really kind of aimed towards a bit more of a practical understanding of physics. Is a challenging paper. It's a bit shorter, 1 hour 30. Both the other papers have some multiple choice and some longer answer questions. The paper 3 is just longer answer questions. And then alongside this, there's something called the practical endorsement, which just means that that's a pass or a fail, and it just means that you've been assessed on practical skills throughout the 2 years of the course. Practicals are divided into 12 groups, 6 of them that you do in year 12 and then the other 6 in year 13. That doesn't mean that we only do 12 practicals. Within that group, you have to have done a practical within each group, but we try and do as many practicals as possible within the groups. And quite often the academic questions in the A-level papers will have some basis on practicals that you will recognise. And they do like to ask academic questions on practical work in written papers. So we really try and make sure that we're out of our seats doing practical work whenever possible. That goes in me, Mr. Bainbridge and Mr. Smith in year 13. We're all really keen to make sure you're good practical physicists. What sort of grades make you a suitable candidate for an A-level physics course? Well, I think in an ideal world, you would be getting a 6 in your science at GCSE. So 6 in trilogy, or if you're doing separates, 6 in physics. But alongside that, you've really probably got to be aware that the course is really quite mathematical. And especially if you're not planning on taking an A-level in maths, you need to make sure that your GCSE competence is high. So I've suggested there to feel confident on the course, a 6 or a 7 at GCSE. And that especially would be in algebra and kind of logs, surds, things like that. Probably the harder end of the GCSE course is the part that I need you to be confident with. It is a good idea to study a maths A-level, but it's not a requirement of the course. The course is designed for somebody who is not studying maths A-level to be able to cope with it. Though saying that, if you're not doing maths A-level, you probably do have to think that you need to be prepared to put some extra work in, either before school or after school. You might have to turn up for a little bit of extra support in the maths. Generally, we have exams at the end of year 12. That has been the normal habit, but normal at the moment is a bit not normal. And that would just check that you are ready to proceed into year 13. What are my expectations of an A-level student? So alongside your hours in class, I would expect you to do about 6 hours of work outside of the lesson, which I don't think is unreasonable. You do have more free time, you don't have a full timetable, some work at the weekend, some work after school. I don't think that's a very enormous amount of work to do. Good attendance at the 6 lessons in school, not being late, being punctual, being organised and proactive. I want to be able to treat you, or we in the physics department want to be able to treat you like you're young adults, not like your old year 11s. And if you need to, come and find some help before school or after school. And that could be for support, or that could be for some extension. So what do we do? Teaching staff at the moment, it's me and Mr. Bainbridge for year 12 and me and Mr. Smith for year 13. I would say that the atmosphere we aim for in class is fairly relaxed, fairly mature. We'll treat you like grown-ups, but it has to be purposeful. So relaxed but busy. I think we do have high expectations, and we also have a lot of experience in a range of different kind of areas of physics. We are definitely approachable and definitely supportive. In particular, I really love helping people who want to really push themselves forward and do kind of some higher calibre kind of applications to universities. That could be you want to apply for Oxford or Cambridge, you want to do medical or veterinary applications, maybe even dental. And if you ask the current year 13, they will tell you that I am really keen to help them with their UCAS university application forms. I really enjoy doing that. So don't be afraid of asking for help. Thought I'd give you a little taste of what happens to people after they finish their A-level course. I think in general most students do go on to university. 1 or 2 we've had go on to apprenticeships, but the majority do go on to university. We've had students go on to physics courses, just plain physics degree courses, mathematics, a variety of types of engineering. We've had civil engineering, mechanical engineering. I think we might have had one electrical engineer. Radiography, and we do have a few people go off to do computing, maybe somebody who's done physics, maths and computing A-levels. A really good variety of options after A-level, not just university. I think sciences seem to be a very employable subject in a much wider framework. I know this year's been a bit odd and you might be feeling as if you haven't had enough chance to ask questions, find out information. As soon as we're back in school, I'm usually in the office next to G20 if I'm not teaching, and please just pop up and have a chat, or email me and we can arrange to speak. And or another option, I have warned them, ask year 12 and year 13. They will give you the no holes barred, nitty gritty story on what A-level physics is like, the pros and the cons. They have been warned, they're expecting your questions. Well, I'm hoping for a bumper load of applications this year, in particular from girls. Do not be intimidated by physics. It's a perfectly good subject for a girl to do. We've had an increasing number of girls since I started, which is really fabulous. Boys, I want you as well, obviously. Don't think that it's just for the girls. A good mix is the perfect class for me. So any questions, do get in touch, and thank you very much for listening.